Welcome back, everybody. This is the final lesson, Lesson 3 in the 3D Printing Design for AutoCAD course. Up to this point, we've covered a few things. We've covered the general layout of AutoCAD's user interface, some general concepts in 2D drawing and 3D modeling, and some commonly used drawing and modeling commands and concepts. In this final lesson, I want to cover some topics that will increase your drawing skills and make your modeled objects even better. In this lesson, I'm going to group the topics into FFF categories. That means each category is going to use the Fused Filament Fabrication Alliterative format. It doesn't really mean anything, I just thought it would be fun to do. Okay, let's get started. Today's lesson is going to cover having a focus for features. This includes overhangs, supported and unsupported walls, holes, escape holes, and minimum features. Next is further finger fiats, which are loft and shell. Finally, we will cover frequent forays into firsts. Let's get started. Let's begin with having a focus for features. This is the section where we talk about object details that are directly affected by the 3D printing process. As discussed in previous lessons, some of these features will exist or disappear depending on how it's oriented on the print bed. First up is overhangs. This section should really be called overhangs and supports because they do go hand in hand. Now, what is an overhang? Great question. An overhang is that part of the model that has no material underneath it when it prints. So for today's purposes, you can think of overhangs in terms of a little or a lot. So here we have a set of different angles, and when the slicer Cura considers whether supports are needed, it measures the degrees from a vertical line. So typically anything over 45 degrees is recommended. So I've taken the liberty to add these angles to here, so you can see that this is 15 degrees, 30, 45, 60, and 75. So anything that goes above 45 degrees, which means it leans further than 45 degrees off of the vertical line, is when a support is recommended. Now, if you think about a typical building, its outer walls are typically perpendicular to the ground. If that building were to be 3D printed, 100% of every layer would rest on the layer underneath it. What if, however, you wanted to print, say, the St. Louis Arch? Now, this shape has no parts that are perpendicular to the ground. That means that each layer is scooted over just a little bit closer to the other side until both sides meet in the middle at the top. Because each layer is moved over a little bit, there's some small portion of the layer that isn't laid down on anything. This part is the overhang. Toward the bottom, the overhang is hardly noticeable because its angle is practically vertical. Now, towards the top, however, the overhang is quite severe. To alleviate issues like this, you can change the shape to minimize the overhang to reduce or even eliminate supports altogether. Here are a couple of examples. So here is a box that is a hole, and you can see the red lines are the layers themselves of the model itself. So the hole is a rectangle. So if we zoom in on this hole, we can see that the layer is laid down and it stops printing for a minute and then it resumes printing across, and it'll just do that over and over and over as the layers build up individually. Now, in this case, the overhang is this top layer here. Now, what's going to happen in this case, as this top layer is printed, as the print head moves across, the liquid plastic that comes out will have a tendency to sag across the middle because it has so far to stretch. So one of the things you can do is to change the shape of that, and you can turn it into an arch. I've drawn these individual lines to show the distance of what the overhang is. And so when you're at the bottom here, you can see that the distance from one white vertical line here to the next is small, but as you get higher and higher and this arch steepens, the distance gets farther and farther. That means there's more and more of an overhang until the overhang gets as long as it can possibly get here at the top of the arch. So these are the kinds of things that you want to consider when you are designing your shapes. So here is another example to alleviate that. So let's say that I wanted to make this hole to where there was no overhangs. I have created this corner here where there is a uniform overhang all the way across the board. This is a 45-degree angle, so I could print this with very little overhang so that supports aren't needed. So let's say that I did want to create something with a curved wall. I can put a little notch here at the top. It doesn't have to be as extreme as this, but you'll notice that this has a pretty wide gap right here at the top, but if I put a notch in here, you'll see that back again at 45 degrees, it's minimal enough to where supports aren't needed. Now there will be a lot of circumstances where you will have a part that has an overhang somewhere on it, no matter how you orient it on the print bed. But if you consider this during the designing stage, you can minimize the post-processing steps later. Okay, so let's talk about supported and unsupported walls. Now it's possible that an overhang could turn into a supported or unsupported wall if it's reoriented on the print bed. Now an unsupported wall is a part that is connected to the overall structure at just only one side. This characteristic increases the chance of warping or detaching from the print. A supported wall, this is a part that is connected to the overall structure at least two sides. This characteristic minimizes the chance of warping. Alright, so let's talk about 3D printing holes. So 3D printing does affect the accuracy of holes in terms of size and the shape. So let's talk about when we're going to print a hole vertically or when we're going to print it when it's in a horizontal state. So let's take a look at this little diagram here. I'm going to turn off my grid mode to see it a little easier. So here on the left, we have a hole that's printed vertically, and you can see the top view here. And here on the right, we have the hole that's printed horizontally. So what'll happen is, if you'll notice that this is the nozzle tool path right here at the center line, and the dark shaded area is the intended size of the layer. And the gray is the actual size of what's going to happen. And so let me show you what that looks like. So if we printed this vertically, I'm going to go down here, and now this is a side view cross section. So you can see what's going to happen is when the slicer slices the part, it thinks that it's going to be a certain height and width of each layer is going to be. So that's this section here. That's going to be as it comes out of the nozzle. What really happens is you can see that it actually compresses a bit. Now this is exaggerated, but just to give you a visual, you can see what's happening. So when this hole is laid down, the slicer understands that this is going to be the diameter of the hole. What really happens is when this compresses, this squeezes out a bit, and so the diameter of the hole kind of narrows a bit. So you can see that 3D printing does affect the size and the shape. Now, depending on the size of the hole, this may not be a problem, especially if you're going to tap this for threading or something like that. That might actually give you a little bit more material to grab onto. But if you're going to feed something into this, then this might actually be a problem. You might need to drill this hole out later on in order for it to fit properly. So let's talk about printing something horizontally. So here, if we printed a hole horizontally, you'll notice here in the blue, this is the intended shape of that hole. It is an actual circle. What would happen if this was printed horizontally is that the material all would collapse a little bit and it would end up in an ellipse rather than an actual hole. So again, if you had a part that was going to fit in here, this would even be more of a problem because your piece that's going to fit in here may not fit exactly because the shape is now changed overall. It's not just a shrinking of the hole that you can drill out. And you might be able to do that with the drill, but just be advised that the deformation is going to be more extreme with a horizontally printed hole. So keep those things in mind when you are designing your part for 3D printing. All right, let's move on to escape holes. A fundamental presumption about using supports is that the supports themselves will be able to be removed once the print is complete. There are times, however, where a part needs supports, but the shape itself makes it difficult to remove those supports. Let's take a look at an example. All right, so I'm going to adjust my view here a bit and change this to X-ray view. All right, so this object is hollow, as you can see, and it's got 3 escape holes here. I won't call them escape holes, it's just the part has 3 holes built into the design. Now you can kind of tell, regardless of the orientation that it's going to be printed, it's going to require supports. The problem is that these holes aren't really big enough to allow you to remove those. So in a case like this, you'll probably need to slice this part at a plane somewhere in the middle to allow you access to the interior. Now after the parts are printed, you can glue them together or use some other method of adhering these parts. So let's see what slicing it in half would look like. Here's another example of that. So here I've just taken somewhere along the middle, put a plane there and sliced the part. So I can just move this out of the way can rotate this. So now I could print both of these parts, and neither of them would require supports. However, it will need a little bit of post-processing by gluing or bolting these together somehow later on down the road. All right, let's move on to the last section in the Focus for Features category. I'm going to jump out of AutoCAD and jump into Cura, the slicer, to better describe what this means. So when I open up Cura, I've already downloaded a couple of parts somewhere from the internet and put them here on the print bed to demonstrate what minimum features is. So here I downloaded a couple of parts off of the internet, and one is a drag-in of some sort, and another is some components to a model house, and you can just kind of see that they're sitting here on the print bed. Now when I click on any individual model, you'll notice it highlights in blue, and it just kind of shows the outline of that model. Here in the prepare section, you can see that see what the model looks like, and everything looks okay, and you can see all the individual facets of this part. Now if I were to go over here to preview, let me zoom in so I can better demonstrate this. Preview, as you recall, is what each individual layer will look like when it prints. So when I click on preview and hit slice, you can see all of the individual layer lines, like I said, and you'll be able to see the blue outline. But if you'll notice, I'm going to zoom in here at the tips of these wings. If you'll notice, the layers don't go all the way to the edge. At some point, they disappear. So the model is supposed to go all the way out here to the corner, but it doesn't really start till over here, probably a couple of millimeters in. Now this is a model that's probably going to be printed for just an artistic purpose, so this may or may not be an issue. You can see it's a little bit farther in here. It may or may not be an issue for a part like this, or it might actually be if you wanted it to be exactly like the model. Now if we look over here, I'm going to go back into prepare. If you look over here, these are individual windows and slats for a model house. This is just something that I, again, pulled off of the internet. Now, if I go over to preview, you'll notice that there's a couple of these sections where they're grayed out completely. Now, if I click on the part, you'll see the blue outline again. I'm going to zoom in here. You can see that here is where there should be material being printed, but it is so small the printer cannot print something at that fine of a resolution. So it knows what it can and cannot print, and it knows that it cannot print something of this size, and so it'll make the decision not to print anything, and it creates the toolpath. Now if you look here, if I go here, you'll see that this column here, the wall is so thin, when I jump to preview, it disappears entirely. So the point of this is that sometimes at a certain scale, parts of your model may or may not print. So be mindful that although a full-size part may print without a problem, an alternate version may need to be designed if you intend to print a scaled-down version. Also be advised that the scaled-down version may lose functionality or resolution. All right, so let's move on to the second category, further finger fiats. And what I mean by that is additional keyboard commands. There are literally hundreds of commands that can be executed in AutoCAD. In this lesson, I'm going to only cover two more, but they're very powerful. The first one is loft. Loft is an action that creates a 3D solid or surface by specifying a series of cross sections. The cross sections define the shape of the resulting solid or surface. Now, while there isn't technically an upper limit to the number of cross sections, you must specify at least two. Let me demonstrate. So what I'm going to do is draw a few shapes here. I'll draw a circle. All right, so I have a couple of shapes drawn, and then I'm just going to move them around here. I'm just going to use this object here as my reference point. So I'm going to grab it at this point and move it up by this much to the midpoint. And I'll grab this one and move it up a little bit higher. All right, so I've got a series of cross sections here. I'm just going to create a few copies so I can demonstrate something additional about loft. All right, so here we are. We have 6 of the same set of cross sections, and I'm going to demonstrate how the loft command works. All right, so I'm going to change my view here so it'll be easier to do these as I make the loft command. So I'm going to type in the loft command. So I'm going to click 1, 2, and 3. And hit enter again. So we can see what this looks like. I'm going to change my view here to X-ray so we can better see what that looks like. So that is all 3 shapes. So there's a circle at the bottom, there's a triangle here in the middle cross section, and then that turns into a square or a 4-sided polygon at the top. So let's see how changing the order of the shapes that I click. So I'm going to type in the loft command again. I'm going to get out of it. I'm going to go back to 2D wireframe because it's easier to click loft. And then I'm going to do 1 and then 3 and then 2. And I'm going to try a couple more. I'm going to try to do a different order each time. 3. Let's do 2, 3, and 1. Let's do 3, 2, and then 1. And then finally, let's do 3, 1, and then 2. And then I'm going to go back to X-ray view just so we can see them a little bit better. All right, so here we have 3 cross sections clicked in 6 separate orders. Now, basically, if you haven't noticed already, we have 3 separate shapes that were created out of this. These are pretty much just duplicated. So it is important to note that the order of the cross sections that you click will determine the shape of your overall object. Now, keep in mind that there are a number of different ways to approach the loft command. There are numerous variables that can be tweaked to get even more refined shapes depending on what your needs are. Again, always remember that you can press F1 to open up the help menu and just search LOFT for loft. All right, so let's move on to shell. First off, the shell command isn't a normal command like all the others previously covered. It's accessed through a generalized command, then through some sub-menus. So, like the command hints, shell converts a solid object into a new object that is hollow inside. Now, it's not like it converts the solid into a series of surfaces with no thickness. Part of the process involves setting the wall thickness so the new object is still a solid. When you convert a solid object to a shell, new faces are created by offsetting existing faces outside or inside their original positions. Let's give it a try. The command to access shell is solid edit, and so I still have these solids here that we used for the loft command. So let's try to shell some of these objects. So the command is solid edit. You can see that it's right there, and I'll hit enter. The next menu, you're going to select body, and then the next menu, you're going to select shell. So the first command after you select shell is to click the objects a single time and then hit enter. And then now you're going to insert the thickness of the wall. So I'm just going to put 1 and hit enter. And then I'm going to hit escape to get out of that menu. So you can kind of see this object now has an interior hollow space with a thickness of 1 all the way around it. So that's all well and good. if you want to create a hole in something, but there's no way to access this hole. So most of the time when you create a shell, there's going to be some sort of entryway into that. So I'm gonna just copy this over here. So let's try that again. I'm going to solid edit, arrow key down. I'm not typing the full thing in. I'm just typing in solid and then just arrow keying down and hitting enter to solid edit. Now I will click on body and then shell. Now here, normally I would just click the object a single time to select the object. If I click again, any subsequent clicks on the object are going to be those faces that you're going to remove from the object, are going to be a hole. So I'm going to click it once to select the object, and then I'm going to click this top face up here once to select that top part that's going to be the hole. And now I'm going to hit enter. And I'll do the same thickness of 1 and enter and escape. So now I have this shell here with a hole in it. Now if you kind of look at it, you can kind of already tell what this sort of looks like. Change this to central. It's kind of a cool looking vase that can be 3D printed, and it sort of looks like the angles of this wouldn't require any sort of support, so this might be a good object to 3D print. All right, so that is all for further finger fiats, but hopefully you can see how powerful just those 2 commands are. This sort of leads me into the final section of Lesson 3, that is frequent forays into firsts. What happened with me was that when I first learned AutoCAD was that I tried to make more and more complicated drawings with only just a few simple commands. I think for me it was more like when you're a hammer, everything looks like a nail. I tried to attack every drawing with just a small set of commands that I had accumulated up to that point. For example, I could have created this very same drawing with simpler commands, but it would have taken at least 10 more additional steps. Frequent forays into first is the notion of voluntary doing a deep dive into an area of AutoCAD that you are not familiar with and taking the time to learn everything about that section. So how does one go about doing this? It's basically a 3-step process. 1, pick a frequency. 2, pick a section. And 3, explore to exhaustion. So for pick a frequency, pick a time that you know that you have available, and when that opportunity arises, carve out some of that time for AutoCAD. For pick a section, go to an area that you're unfamiliar with. Now this could be a random area in AutoCAD, or it could be a topic that has already sparked your interest. And finally, explore to exhaustion. Go through the new area and learn about all the subsections. You can do this through the F1 help or YouTube or other websites. For example, let's say that you selected, say, the Modify panel within the Home tab. Now, these AutoCAD lessons so far have covered a few actions within that panel, like move and offset, trim, extend, fillet, scale, things like that. You can see a few of these here. There are, however, many other actions inside the Modified panel that you could benefit from, such as these. Now keep in mind, these items are contained within the Modify panel alone. There are literally dozens of panels and hundreds of different actions in AutoCAD, so it's easy to do a deep dive in virtually any area. This is the great thing about frequent forays into firsts, is that the principle is transferable. Each one of us has our own stable of software that we're familiar with, and within that stable we're more familiar with some apps than others. If you can get into this habit, your technical skills will rise to well above average. Well, that's all for now. Thank you for joining me in this mini course on 3D printing design for AutoCAD. I hope you've learned something. Take care.